everyone. Good evening. So how are you all doing? Yes. Good evening, Disha Bhatt. Yes, I am excited too. Hey Charvi. Hello Surajpal. Hi Rahul. Good evening Bhagyavardhan. Hey Disha. Yes. All right. Good evening Yasharth Kesarwani. Hi Devna Jaykishore. Gurdeep Kaur is here. All right. Yes. Yes. I can see lots of thumbs up in the comment section and the smileys. Yes. Kashif Ishtiyaq Khan. Good evening. Good evening Vartika. Good evening Vinod Kumar. Hello Ambika Soni. Good evening Karthik. Hi Apeksha Pandey. We have Keshri Baghela. Mohammad Tabrez is here. Mohammad Anzar Khan is here. Charvi. Papiya Das. Yes. Yes, exciting and amazing questions, and trust me, these questions are very important from exam point of view, and they will be covering the different topics that you have in surface areas and volumes. Yes. Alright, so there is no glitch at all, so we can continue. My name is Khushbu and a very warm welcome to yet another wonderful session. So we all know what is the topic of today's session, right? Today we are going to discuss some critical questions, some important questions on surface areas and volumes. So let's not waste any more time here. Let's start the session. Alright, ready? Yes? Okay, Charvi is saying ready. Yes, all set for the questions. Great. We have Krishna also here. Yes. Hi, Radha Krishna. Hey, Sakshi Devi. Yes. Okay, you want me to wear Byjus t-shirt? Okay, I'll wear that next time. Yeah. Yes. Yes. Rishit Solanki. For yesterday's homework. Okay. Good evening, B. Indra. Yes. Ready? Sakti Devi, Sakshi Singh. I am doing good. Anshuman Tiwari. Thanks for asking. Hi, Priya. Kiruba J is here. Yes, it's me, _Sagar 900. I can see some new people over here today. Yeah. Alright, so let's start the session. So we have our first question right in front of us on the screen. Some plastic balls of radius 1 centimeter were melted and cast into a cylindrical tube. If the thickness, length and outer radius of the tube were 2 centimeter, 30 centimeter and 10 centimeter respectively, how many balls were melted to make the cube? Let's first understand this question. See, we have few plastic balls, spherical in shape. You can see that these balls are melted. You can see over here in this shape, right? And they are basically, after melting, they are forming a cylindrical tube. Yes? So just imagine in your mind, when these balls get melted, we don't know the number of balls here. When they are melted, whatever material we have, we are using that material only to make the cylindrical tube. Yes. So if you have seen the yesterday's session, what we discussed is, what is happening here? Conversion of solids is happening, right? Question says, and cast into a cylindrical tube. I told you, when you come across such words in the question, that means the volume will remain the same. Yes. Hi, Samyak Jain. Ma'am. Yeah. Yes. We have Suraj Pal, right? Yes. Jayesh Kumar is here. Okay. Right. So here we have spherical balls and we have this hollow cylinder. So definitely we don't know how many spherical balls we have, right? Let's suppose we have the X number of spherical balls, right? So number of spherical balls into volume of one spherical ball. I'm just writing one sphere would be equal to the volume of this hollow cylinder, right? This is what we are going to apply in this question. Yes? Alright, Gungun. Good evening, Jeevni Chauhan. Satyam Kumar is here. Okay. Giriraj Kanwar. You are new here. I hope that you would enjoy this session. Yes. Anshu Raj. Okay. Yes. Firdaus Rehmat. Hello. Alright, so we have understood, right, that we are going to equate their volumes because conversion of solids is taking place here. So what we'll do here is, first of all, we will simply say, let's suppose that the number of spherical balls over here are n, right? You can assume any variable, right? Yes. Jeevni Chauhan, ma'am, you're the best mathematics teacher. Thank you. Hello, Muskan. Hi, Ridhima. Okay, so see, this is a hollow cylinder, right? So we have the thickness, we have the length, we have the outer radius, right? Let's suppose that here outer radius, see, this is the cylindrical tube that we have, right? And this is the center. This is the center Okay, so from the center, let's suppose that the inner radius over here, I'm denoting that with R1. Inner radius, right? Inner radius is R1 and the length over here, this is the length. We denote that by H. And what is the length here? Length is 30 centimeter. So length over here is 30 centimeters. Okay. Thickness over here is 2 centimeter. Thickness is this thing that I'm highlighting with yellow color. This is the thickness, right? That's 2 centimeter and outer radius is 10 centimeter. Outer radius means, let me just highlight this thing. Outer radius means, see this inner circle, this is denoting the inner radius that I'm denoting with R1. And from here till a point on the outer circle, that is denoting your R2, your outer radius. So outer radius over here is what? That's basically 10 centimeter. Thickness is 2 centimeter. So from here I'll get the inner radius, that is going to be what? 10 minus 2, which is basically 8 centimeter. So I hope this much part is clear to everyone, how we are getting the inner radius. Because to find out the volume of a hollow cylinder, what we do is we subtract the outer volume and inner volume, right? So we have pi R2 square H minus pi R1 square H. Let's take pi H common over here. We have R2 square minus R1 square. So we pi over here. And here we have n times 4 by 3 pi r cube. So pi and pi will cancel out. We have 30 here. R2 is 10 square. R1 is 8 square. N times 4 by 3 as it is. And radius over here is, for spherical balls, is 1. First tell me if this much, the step 1 is clear to everyone or not, so that I can move to the next slide. Yes. Rishit Solanki has got the answer already. Wow. Mohammad Anzar Khan. Byjus and its teachers are the best. Thank you. You are super, ma'am. Thank you, Ozzy Lazy. Yes, you got such funny names. Yes. Thank you, Sunita Prakash. Yes. NDA girl, you also got the answer. Okay. Yes. So this much is clear to everyone, yeah? Jayesh Kumar, yes ma'am, all clear. D. Deepak got the answer. Asiya Sarvat Rehmat. You want me to repeat? See, this much step is clear that volume of the cylindrical, this hollow tube would be equal to n times the volume of spheres. Because we are melting these spheres, we are melting these balls, and using the same material we are making the cylindrical tube. Yes? Okay. So we don't know how many spherical balls are here. But what we know here is, I know about, when it comes to hollow cylinders, we have to subtract the outer and inner volume. Yes? Right? So we have the height, that is given 30 centimeter. We have the outer radius, that's 10 centimeter. From this point to this outer point on this circle. But we do not have the inner radius. We do have the thickness. See, inner radius plus thickness will give you outer radius. What is inner radius? We don't know that. Thickness is 2, outer radius is 10. So inner radius is going to be 10 minus 2, that's basically 8 centimeters. Yes? I hope this is clear now. Right? Simply, you put the values here. It's better that you take common, whatever you can take common from here, so that the calculation becomes much simpler. So we have 30 here, 10 square minus 8 square, that's equals to n times 4 by 3 into 1. Yes. What is n here? N is the number of spherical balls. You can assume any other variable. That is also okay. Right? Yes, Jeevni Chauhan, crystal clear. Yes. So, okay. Yes, ma'am, clear. Charvi is saying some students have given the answer also. Okay. So this much step clear is to everyone, right? So from here, simply we will just solve it and we get number of balls as 810, right? Sakti Devi, Byjus is the best learning app for scoring marks. Thank you, Sakti. Yes. Okay, so it's clear to everyone. Great. Let's move ahead. Let's take a look at the next question now. So Kriti bought a refill pack that could fill the bottle of a hand wash a total of 3 times. Now the bottle has a cylindrical shape with radius 3.5 centimeter surmounted by a hemisphere on top. Find the volume of the refill pack. Yes? Why mostly X? Doesn't matter, whichever variable you want, you can use it, right? I know that generally we assume X as the variable, right? Okay. Okay, so not Kriti ma'am, we are just using this name. No. Yes. Okay, Yashat Kesarwani. Yes. So question is already mentioning, right, that we have a bottle of hand wash. Now a refill pack can fill it 3 times. Okay. So this bottle has a cylindrical shape. Okay, this has a cylindrical shape. I can see till here. It is surmounted by a hemisphere. Surmounted by a hemisphere means it has a hemisphere on top of it. Okay. So we need to find the volume of this refill pack. Okay, the entire volume. Now you can see that radius is given, right? And the height is also given. So let's find it out. The first step should be the volume of this cylindrical part. You can see that how this has been segregated, right? How this figure is divided. First you have a cylindrical part. Then you have a hemisphere. I think this color might not be visible. Yes, then we have a hemisphere. So how to find out the volume of cylinder? That's pi r square h. Pi is 22/7. Radius is given. That's 3.5 times 3.5 and h over here is 12. Right? Simply you cancel this 7 with 3.5, you get 0.5. We have 22 into 0.5 into 3.5 times 12. Simplify it, you get 22 times 6 times 3.5, you get 462 centimeter cube. Yes? So that's the volume of the cylindrical part. So this much part we have already got the value. Yes? Okay. Jeevni Chan, Byjus is a superhero. Indeed, the world of education who teaches us always the best and clear all our doubts. I have fallen in the love. Thank you, Jeevni. Yes. Yes, Sonali. Yes, Giriraj Kanwar, you have a doubt? Yeah? Sakti, please refresh the screen once. Yes. Yes, you can ask whatever doubt you have. Okay, okay. So meanwhile, let's move to the next step. So we have to find out the volume of the hemisphere also. I'll give the summary once we are done with the question. Statistics. Yes. See, today we are doing a critical question session on the surface area volumes. Next session is on statistics. Yes. Papiya Das, I'm a big fan of Byjus. I love Byjus. It teaches us visually. Thank you, Papiya. Okay, so volume of hemisphere, we know what the formula is, 2/3 pi r cube. You see both of them are sharing the same base, right? So obviously radius would be same. So we have 2/3 pi, 3.5 cube. Simplify it, you get 89.83 centimeter cube. Yes? I'm not visible. Refresh the screen once because I think I'm visible to rest all the other students, right? Height of cylinder, Anshuman Tiwari, that's given. That's 12 centimeters. See, it's given over here. That's the height for the cylinder. Yes. Adding them and take pi and r common? Definitely. Rishit Solanki. Yes, we can do that. Right. Yes, Giriraj Kanwar, you can ask. Okay. So what we are doing here is simply I'm going to add up their volumes now. Yes. You could have done this way also. You can take pi and r common and then because they have pi common, obviously they have radius common. Right. Okay. So simply we add them up. We get 551.83 centimeter cube. That's the answer, right? So we have got the answer. So is this the final answer? Yes. Question was asking the volume of the refill pack. So you think this is the last step or there is something else needs to be done? Quickly. Is this the final answer? Yes. Rashad Kesarman, easy peasy? No, nope. So what do we need to do further? Question says a refill pack could fill the bottle of hand wash a total of 3 times. Yes. So what do we need to do now? Yes, multiply by 3. Absolutely, Kashif Ishtiyaq Khan, right. We have to multiply this by 3 now because a refill pack could fill it 3 times. Yes, yes. Multiply this value by 3. So we get 1655.49 centimeter cube. That's the final answer now. Radius, Sarthak Jadhav, it's given. See, they have a radius of 3.5 centimeter. Both hemisphere and cylinder have a common radius. They are sharing the same base, right? So radius is same. Centimeter cube, absolutely. So we have all of us have understood, right? How to find this out. Great. Okay, let's move ahead. Let's take a look at the next question now. Asiya Sarwat Rehmat, crystal clear? Fenil, is giving a thumbs up, easy one, yes? Great. Third question. So it says the height of a cone is 30 centimeter. Okay, let's make a cone here. Let's make a cone here. It has a height of 30 centimeters. Okay, we have the height of the cone, right? I'm writing here 30 centimeter. I'm just making a rough sketch first, right? I'm not very good with the drawing, so just showing you a rough sketch, then I'll show you the proper figure. Yeah, radius same hai, warna hand wash गिर जाएगा. Yes. Okay. Okay, Gungun, you're back. Great. So whatever you have missed, you can watch the recorded session later on. Yeah. Okay, so a small cone is cut off at the top by a plane parallel to the base. So a plane parallel to the base, we are cutting a small plane over here. Okay, so now we have a small cone above, right? Okay, then the volume of this cone, I'm just highlighting it. The volume of this cone, smaller cone, is 1/27th of the volume of the given cone. So volume of small cone, right, That's equals to volume of bigger cone. This, I'm sorry, not equal, it is 1 by 27th of the volume of bigger cone. This is what question is saying. Yes? Okay. Byjus is a superhero. I'm sorry, I could not read the entire comment. Wait a second, Surajpal. Yes. Wait a second. Everybody started writing. Frustum is deleted. Frustum is deleted. See, understand the entire question first. Yes, frustum is deleted. I'm not discussing frustum over here. You must have seen these kind of questions in the reference books. This figure, that's why you are saying frustum is deleted, right? But this is not a question from frustum because, see, they can even, just modify the question a little bit. Yes, okay. So, we have to find out what height above the base is the section made. What does this mean? What height above the base? This is the baseline. At what height above the base was the section made? That means at what height above the base we have cut this thing. So I need to find this white part over here, right? This much part that I've highlighted here. Yes. Okay. So we need to find this thing. This is what question is saying. Now let's take a look at the proper figure. So we have a bigger cone over here and you can see that we have labeled this as, this is A, O, B, this is the right triangle here and we have cut it from here, this is C, this is D. Obviously these two angles are going to be 90 degrees, right? Yes. Papiya Das. Okay. Frustum. See, if you remove this smaller cone from above, from the top, this much part, this is nothing but that's the frustum. Yes. A steel bucket if you have seen, right? That's basically a frustum. Yes. Or I can give you a very simple example. Lassi glass, if you have seen that, the bigger one, right? It's like this only. That's a frustum shape. Yes, Ashu Kumar, I do remember. Hello, Saif Pasha. Okay, you just joined. CDOB, not CDOB, I would say, not CDOB. This entire part that I'm highlighting here, this is representing a frustum, right? You have seen this shape in your real life also. A steel bucket, as I said, lassi glass, yes, that's the thing. Okay. Yes. Yes. It has base. Which base? Yes, this is the base here. This is the base, right? This thing, this entire thing, if you think about it, that's a frustum. Okay. That's okay, Surajpal. Now, the question is saying that this bigger cone has a height of 30 centimeter, right? This entire height is 30 centimeter. Now, a section is made from here. Right? So we have a smaller cone. Question is saying that the smaller cone its volume is 1 by 27th of the volume of the bigger cone. Yes? Okay. Yes, lassi ka, pani peene ka, etc. Because generally glasses have different shapes, right? When you see in the market, right? So the glasses which we used to use in earlier days, like it has this shape. Okay. So let's say this is, see, I'm not discussing frustum. Please pay attention. Let's suppose the radius and height of the original cone. Let's suppose this has a radius of, original cone, this has a radius of R and its height over here, that's 30 centimeter. Capital H is denoting 30 centimeter, right? Just to avoid confusion, we are denoting them with different variables. And radius and height of the smaller cone with small r and small h, right? So this cone has a radius of small r and height of small h, okay? Yes. Okay. So volume of the bigger cone. The first one is 1 upon 3 pi r square h. That's very simple. 1 upon 3 pi r square. What is h? H is 30. We do not have the value of radius. I'll keep pi and radius as it is. So 10 pi r square. Right? Okay. Coming to the next step, volume of the new cone, the smaller one. This is 1/27th the volume of the bigger cone. That is 1 by 27 of 10 pi r square. Yes? And the smaller cone has a volume equal to this. That's 1 upon 3 pi r square h. Correct? So simply what we can do from here is, I can cancel this out, right? So we can say that this is 3 times 1, 3 times 9, right? So we have 10 pi r square equals to 9 pi r square h on cross multiplying this. Yes, so pi and pi will get cancelled out. Okay, so what do we have at the end? We have h equals to 10 upon 9 r by r whole square. That's our equation number 1. Yes. I hope this much part is clear to everyone. I'm not discussing frustum. Yes. Okay. Let's move ahead. So we have framed an equation. Now we are all aware of this similarity, right? We have learnt about the triangle similarity. Take a look at this triangle, this ACD and this bigger triangle AOB, right? In both these triangles, if you see, we have 90-degree angle, right? Over here, you can see, yes? And we have this common angle A over here. So by AA similarity, I can prove them similar. When triangles are similar, their corresponding sides are proportional. Yes? Okay, so we have corresponding sides are, we have R here, small r here. So R by R, height of the bigger cone is 30, height of the smaller cone is h equals to 30 by h. From the first equation, we got this thing. So I'm putting everything here. 10 by 9 equal to 30 times 30 upon h by h. You get h cube as 1000. H is 10 centimeter. So which h we have got? We have got AC. But what question is asking? Question is asking the CO. So from entire 30, I'll subtract 10. So we get 20 centimeter. That's the final answer. Yes. Yes. You want me to explain one more time? Yes. Okay. Some students are saying to explain one more time. Right from the beginning. So this much part is clear, that the volume of the smaller cone is equal to 1 by 27th of the volume of the bigger cone. Right? I hope this much part is clear to everyone. Yes, I'm explaining one more time for the ones who haven't understood this. Yes. Is this step clear, that volume of the smaller cone is 1 by 27th of volume of bigger cone? Quickly. Yes, write in the comment section. So I'll start from here. Then. Yes, I'm waiting. Yes. Okay. Okay. So this line says volume of smaller cone is 1 by 27th of the volume of bigger cone. Okay. So what is the volume of smaller cone? That's 1 upon 3 pi r square h. It has a radius of small r and height of small h. Yes. Okay. Okay, okay. And the volume is equals to 1 by 27, the volume of bigger cone, 1 upon 3 pi r square h. This much step is clear? This is written in the question. I'm just writing that into a mathematical form. Yeah? Okay. Now, what we can do here is simply, you can just put the values here. 1 by 3 gets cancelled. Pi and pi gets cancelled. Right? So, what do you have here? You have 27 r square. Do we have the value of small h from here? No, we do not have the value. We have 1 by 27, right, into what? That's equals to r square h. R square, and what is h here? That's 30. That's 3 times 10, 3 times 9. Is this clear? Formulas is one thing that you need to remember. That's the most important part for this chapter. Yes? One is to understand the question. Second, remembering the formulas. Calculations and all, don't worry, I'll tell you. I'll give you some ways how to solve faster. Don't worry about that. Before the exams, we'll prepare you well. Okay, you can see loads of thumbs up. It's clear to everyone. Great. So what do we get from here on cross multiplication? What do we get? I'm writing here only. I know that entire slide has got really messed up. So we have 9 r square h equals to 10 r square, right? Equals to 10 r square, right? So from here, if I take this to one side, so what do we have? We come to this step, right? H is equals to 10 by 9 r upon r whole square. Yes. So I leave it here only because I do not have the value of the capital R and small r. Teaching style is so fantastic. Thank you, Satyam Mangal. Yes, we can, if you're given the angle, which is not the case in this question. It's okay, you're answering to his question. I don't know, what did he ask? This much is clear, yes? Okay. All right. So once we have this equation, all I need is the value of these r's. So how do I get this value? To get the value, what we are doing here is we are applying similarity. Yes, similarity here. So I can prove this small triangle ACD and this bigger triangle AOB similar, right? How? This angle is 90 degree, this angle is 90 degree, this angle is common amongst both of them. By double A similarity, I can prove them similar. When triangles are similar, we can say that their corresponding sides are proportional. That means capital R by small r, considering the bases, corresponding sides you see. Then I consider the height of the bigger one, which is 30, height of the smaller one is h. Right? We come to this step. Okay, it's clear. Great. So what I'll do here is, from the first equation, which is h equals to 10 by 9, that was h equals to 10 by 9 r by r whole square. What is r by r? That's 30 by h. Put it here, 30 times 30, h by h. So what do you get from here? This is 3 times, 3 is 9, 3 times 10, 3 times 1, 3 times 10. You have 1000. Cube of 1000 is 10. So we have got 10 centimeter as h, but I do not need h. I need CO. That's 30 minus 10, which is 20 centimeter. Thank you, Saif Pasha. Yes. ऑल राइट डी दीपक, सबसे मस्त अपनी लाइफ है, ये लेसन और स्टेटिस्टिक्स डिलीट किया है. ग्रेट. क्रिस्टल क्लियर? यस. Okay, okay, great. Now let's move ahead. Let's take a look at the next question now. Yes, frustum of cone is deleted, but in this question, you see, I did not use the concept of frustum. So these kind of questions might be asked in the exam. Yes, and these kind of questions have come up earlier in the previous year papers also, if you see. Great, let's take a look at this question now. The water in a rectangular reservoir has a base of 80 meter by 60 meter, right? When it says that it has a base of 80 meter by 60 meter, if you look at this reservoir over here, which has got water in it, this is the length and this is the width, right? And it's 6.5 meter deep, that means this is the height. It's a cuboid, that means, right? Okay. And in what time in hours, we have to find out the time in hours, can the water be emptied by a pipe having a cross section in the form of a square of side 20 centimeter if water runs through the pipe at the rate of 15 km per hour? Trust me, these kind of questions are actually asked in the exam. They're actually very important from exam point of view. And I've seen most of the times here students get confused here a lot because they're not able to understand the concept. They try to mug it up actually. Yes? Okay. Alright, so let's first understand this. We have a reservoir here, right? You can see that it is cuboidal in shape. It's got length, width and as well as height. Now we are using a pipe over here which has got a square cross section, right? And its side is also given. A pipe is connected to it. We are using this pipe to empty this reservoir, right? Now question is asking how much time it will take, and we have to find out that time in hours. One thing you need to understand, see, whatever amount of water this reservoir has, right, the volume of water that it has, see, it all depends on this pipe. Whether this pipe is bigger, this pipe is narrow, it all depends on this pipe, that how much time it will take to empty the entire tank. Yes? Correct. Rishit Solanki, yes, your question is right. Gulab Jamun question, yes, it's an important one. It's a question from your NCRT only. Yes, these kind of questions, they do ask in exam. Bhavna Kumari, sorry, I see it's sometimes it's really difficult to read the comments of each one of you. I might have missed. Could you please ask me what your doubt is? Yes, yes, yes. Cube minus tube? No, 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 no. General Joshi, no. How can we subtract them? See, understand this. See, it all depends on this, the volume of the pipe, of this pipe, that how much time it will take to empty it. If it is a narrow pipe, it will take longer time to empty the reservoir, right? If it is a bigger pipe, right, it will take less time to empty it. Agree? Okay. So first of all, we need to know what the volume of this reservoir is actually. How much amount of water this reservoir has got. Okay. So we know how to find out the volume of a cuboid. That's L times B times H. We are given all of them. So it's 31,200 meter cube. That's the volume. That's the volume of water this reservoir has got. Correct? I can see these answers over here. Wow, amazing. Now, since we have connected this pipe with it to empty it, right? So, to empty this, first of all, we need to know, because we are given that it has a square cross section. It's 20 centimeter, its side is 20 centimeter. Let's convert this into meter first, because rest everything is in meters here. That's going to be 0.2 meters. I can find out its area. That's 0.04 meters square. Remember one thing, whenever you are given the speed in such kind of questions, you can convert that in length. The speed can be converted into length. You can convert this in length. How? It says that water is running at a speed of 15 km per hour. That means in 1 hour, it covers a distance of 15 kilometers because it runs along the length. It flows along the length. Correct? It flows along the length of the pipe. So in 1 hour, it covers a distance of 15 kilometers. I can say in 1 hour, it covers a distance of 15,000 meter. Correct? So we have learned one thing, that volume is nothing but that's actually area multiplied by height. Yes? Yes, it's an important chapter. Kanagu 001. Yes. Correct. So obviously this length, when I multiply that with area, I'll get the volume of this pipe, which is 600 meter cube. Now, as I told you, it all depends on the volume of the pipe, how much, how much time it will take to empty the reservoir. Correct. We could have emptied the tank directly, right? We could have inverted it directly, right? Why we need to do so much of work? Yes, Papiya Das. Wow, what a good idea. Yes. How height? General Joshi. See, remember one thing. Speed can be converted to length. How? It says water is running at a speed of 15 km per hour. That means in 1 hour, it is covering a distance of 15 km. So obviously water runs along the length of the pipe. Yes. So it will give you the length, the height you can say. You can say height also. Yes. Okay. So this 15 km, I can write this as 15,000 meter also. Yes. Alright. So this is clear to everyone. Yes. Thank you, Melissa Priju. Hi, Mispa. Bye. Yep. Correct, Suraj. What is the need of math then? Yes, Fenil, right. यही आंसर में क्वेश्चन में लिखाएंगे तो फुल मार्क्स आ जाएंगे. Yes. Crystal clear. Great. Okay, let's move ahead. So we have the volumes of both of them. All we need to do is we will simply divide them. So we get 52 hours. Or you can say that the time required, multiply that with the volume of this smaller pipe, is equal to the volume of reservoir. Correct? That way also you can say you divide them, you get 52 hours. That's the final answer. Yes, Prachi Sharma, one more time. Volume is area multiplied by height. Yes, Ananya, you can check with any of the 3D figures, right? If you have seen the previous sessions that we have done, let's take an example. Let's suppose I'm talking about a cuboid, right? You know that we can convert a 2D figure into 3D figure, right? So 2D figure is a rectangle. If you keep piling up rectangles of the same dimensions on top of each other, think about it. What do you get? You get a cuboid. Rectangle has got length and breadth only. Sorry for my drawing actually. Has got length and breadth only. If I keep piling up rectangles of the same dimension on top of each other such that they reach a certain height up to edge, what we get? We get a cuboid. So area of rectangle is nothing but that's actually L times B. And if I multiply height with it, what do we get? We get area multiplied by height. This is nothing but that's volume of cuboid. Similar with cubes also. If you keep piling up squares, squares are 2D figure. It has got all the sides equal, right? It doesn't have a height. If I keep piling up squares of the same dimension on top of each other such that they reach a certain height, we get what? We get volume of cube. So you see a 2D figure converts into 3D figure. Similar with a circle also. Circle has an area of pi r square. You keep piling up circles of the same dimension on top of each other so that they reach a certain height of edge. You get a cylinder. That's why we say that we multiply area with height to get volume. Yes? Understood, Ananya Kukreja? Yes. टैंक को उल्टा करेंगे. अरे वो टैंक तो देखो, उसको उल्टा कर सकते हैं क्या? यस, दैट ऑल्सो नीड्स टू बी चेक्ड. उसको उल्टा कर सकते हैं. राइट फेनिल, एब्सोल्युटली. ओके, आई एम एक्सप्लेनिंग दिस क्वेश्चन वन मोर टाइम. वी हैव अ reservoir here filled with water, right? Whatever, we find out the volume of the reservoir. Why? So that we get the total amount of water in it. Yes? Let me tell you the crux of this question. Now it is connected with a pipe it has a square cross section, side is given, right? So think in your mind, it all depends on the volume of the pipe. If it is a narrow pipe, it will take longer time to empty it, right? If it is a bigger pipe, it will take lesser time to empty it, right? Agree? So here, what we are doing here is, it all depends on the pipe, and time also depends on this pipe which is connected to it. What I'll do is, I'll simply multiply the time with this volume of pipe. That would give me the volume of the reservoir. So this is basically the crux of the question. Has everyone understood this? And how we are coming to the volume of this pipe? We are just doing area multiplied by height. Remember one thing, even if you have questions in the NCERT, you have questions in other reference book like R.D. Sharma, R.S. Agarwal, whenever you have speed, you can convert that into length using just this concept that in 1 hour it's covering 15 kilometers or whatsoever the digit is, right? Because water runs along the length, right? Yes, Fenil, I always check the answers. I always check who all have actually answered to it. Yes, Gulab Jamun question is important. That could be asked. Yes. Rosna, volume? Yes, volume is what? That's area multiplied by height. You can check with any one of them. Let me remove this. See, for cuboid. Cuboid is made from a 2D figure rectangle. So we have what? L times B times H. L times B is what? That's area of rectangle. Area of rectangle times height, you get cuboid. Let's talk about the volume of a cube, let's say. So for volume of a cube, what is it? It's side multiplied by side. Let's suppose side is A. A times A is what? A square. That's nothing but that's actually the area of square. So area of square multiplied by A. A is nothing but that's the height. Yes, you get the volume of cube. No, Keshvi, those questions are important. I would suggest you that you should practice those questions. I hope it's clear to everyone now. Yes, Yasharth, I know you responded to it. Yes, I always check that. Okay. Really, Suraj? Is it so? Although maths, generally we say that it's the most difficult one. But still, यहाँ पे ज़्यादा मजे हो रहे हैं. Yeah? Yes, Vasudev Das. No need to be fear when Byjus is here. See, it all depends. It's not necessary that the questions will be asked from NCERT only, but yes, they will be based on your NCERT. Yes, whatever concepts are there, questions will be NCERT based, but we cannot say they will be directly picked up from NCERT. Yes? Sure, Janil. Yep. Okay. Thank you, Suraj Pal. Okay, great. So it's clear to everyone. Let's move ahead. Let's take a look at the next question now. So in the given figure, the height of a solid cylinder is given. That's 10 centimeter. Pay attention to the question first. Understand this properly. We have the height of the cylinder. That's 10 centimeter. Diameter is 7 centimeter. So that means we can get the radius from here to here. It's basically 3.5 centimeter, and you can use 7/2. Right? Now, two equal conical holes of radius 3 centimeter and height 4 centimeter are cut off. So from here, conical cones we have cut out. And equal conical cones we have cut, right? Radius and height is given. Find the total surface area of the remaining solid. So this is something, I have seen that student get confused here. See, had it been volume here, what we would have done, simply we would have subtracted the volumes of the two cones from this volume of cylinder. But this thing doesn't work with areas, because area is what? Area is something that, you need the surface. Area talks about the surface actually. Yes. So what we will do here is, I need the surface area of the remaining solid. Now imagine in your mind, let's suppose we have an ice cream brick. Okay, imagine all of you must have eaten or seen the ice cream brick, right? I'm sure. So when you have an ice cream brick, it's cuboidal in shape, right? And when you scoop out ice cream from it, obviously there will be a hole in it. Yes. So if I ask you to find out the surface area of the remaining shape, what would you do? You would simply find out the surface area, right, of the cuboid, right? From there, you would add up the surface area of that hemispherical scoop, and you would subtract the area of the circle also, because on the top nothing is there. This is what you're going to do. Yes. Same thing we are doing here. What we will do is, we have the diameter, we get the radius. Okay, this is simple. First, I need the surface area of the cylinder. Why? Because we need the curved part first of all. This is simple. I'm not taking the total surface area. You see, I'm taking the curved surface area. So till now, we are not talking about the top. We are not talking about the bottom. So we get 2 pi RH. That is 2 times 22/7 into 7/2 into 10. That's 220 centimeter square. Correct? Okay. Now, cone has a radius of 3 centimeter and height of 4 centimeter. To find out its curved surface area. Why curved surface area? Because we need the area of its curved surface. Right? We do not subtract areas like that. It is not volume. Volume is telling us about the capacity, right? Amount of material something has. So here we would require the area of this conical part also. So we find out the slant height using the Pythagoras theorem. That's 3 square plus 4 square under the root. So you get 5 centimeters. We have the slant height. So pi RL is 22/7 into 3 into 5. That's 330/7 centimeters square. Yes. CSA of cylinder, curved surface area of two cones. Yes, we need to do that. Absolutely, we will do that. Now, so CSA of cylinder plus 2 times curved surface area of two conical holes. That's 220 plus 2 times 330/7. That's 2200/7 centimeter square. That's the answer. Yes. Okay. All right. So I think it's clear to everyone, yes, that we have to consider those surface areas. Right? Okay, let's move ahead. Let's take a look at the next question now. A conical vessel of radius 6 centimeter and height 8 centimeters is completely filled with water. Now this conical vessel, imagine in your mind, it is completely filled with water up to the brim. A sphere is lowered into the water and its size is such that when it touches the sides, it is touching the sides, you see, it is just immersed in it. Yes? So what fraction of water flows? Think about it. Let's suppose you have a cylindrical bucket, okay, completely filled with water. Now, when you put a spherical ball in it, so some amount of water will come out. Now it all depends on the volume of that spherical ball. If it is a smaller ball, then little amount of water will come out. If it is a bigger ball, more amount of water will come out. It all depends on the volume, right? Yes? Okay. So what we could do here is, this is the conical part. Yes? So from here, this is given that this radius is 6 centimeter. Inside this we have a spherical ball. It is touching its sides. We do not know its radius. Let's suppose that is r, and let's suppose this angle over here is theta and this height is 8 centimeter. See, these kind of questions are very important. Please pay attention to this. Yes, absolutely, Ishad Kesarvani. So we have AC. AC is 6 centimeter. Where is AC? AC over here is this. This is 6 centimeter. Right? We have OC, this entire thing, this entire height is 8 centimeter. PD and PC over here, this PD and this PC over here, they're all equal. They're r, small r, we are denoting them with small r. Okay. So since we know that length of tangents drawn from an external point to a circle are equal in length, right? So this AC over here and this AD over here, they will also be equal, right? This is the external point. These are nothing but these are the tangents to the circle. Yes, Papiya. Nice. What a good idea again. Papiya always gives us good ideas, right? Okay, answers are also there. Great. So we know one thing, that this triangle OCA, this OCA, this one, and this OPD, this one that I'm highlighting here, both of these are right triangles. Yes. And tangents and radius are always perpendicular to each other at the point of contact. Okay, cool. So from here you can get the OA, right? This is 8, this is 6. Using Pythagoras theorem, you get 10 centimeter. Similarly, I can get OP. Yes, OP also. This is what? From this right angle triangle, I can get the length of OP. OP would be what? OD square plus PD square. What is OD? OD over here is nothing but that's OA. From the entire OA, you subtract AD. OA is what? That's 8. AD is what? That's 6. So you get what? You get 4 centimeter. And this is r over here. So using Pythagoras, I can say 8 minus r whole square equal to 4 square plus r square. Okay. Open it up. Whole square. So 64 minus 16r plus r square equal to 16 plus r square. You get radius as 3 centimeter. Yes. Hi Anshika. You are new here, but you have missed a lot of questions now. But it's okay. You can watch the recorded session later on. Yes. Okay. Clear. Let's move ahead. So what we are doing here is, the volume of water that will overflow when we put the sphere inside it. So volume of water that overflows would be equal to the volume of sphere, right? Yes. Have you understood this thing now? That's why I told you, let's suppose you have a cylindrical bucket. Fill up to, you can try this out try this out by yourself. You have a cylindrical bucket and it's completely filled with water up to the brim. You put a ball inside it. You can try with different objects, because different objects would have different volumes, right? You can try with a rubber, you can try with a smaller ball. You would see that every time different amount of water will overflow, because that depends upon the volume of that object. So here volume of sphere will be equal to the volume of water that overflows. Janil, I hope that your doubt is clear now, right? You were asking about subtracting them. Yes, I haven't removed it from the conical thing. Suraj, okay. So what we are doing here is, it says that we have a conical flask. Water is filled inside it. When I put the ball in it, the ball is touching its sides. So some amount of water will overflow, definitely. Now, according to, if you think about Archimedes' principle also, it all depends upon the volume of that object, right? So volume of sphere would be equal to the volume of water overflown. So to find out the volume of the sphere, we required radius. We did not have the radius. That's why we did those 2 steps before this, to get the radius of this thing. So we applied Pythagoras on this smaller triangle and on this bigger triangle also to get the value of the radius. Okay. So from here we get 4 upon 3 pi r cube. Keep pi as it is. So that's 4 upon 3 pi 3 cube. That's 36 pi centimeter cube. I hope, yes. Radius, Ananya, how to find out the radius? See, what we are doing here is simply this bigger triangle, OCD, this has a height of 8. It has, this length is 6. So you can get OA from here using Pythagoras, that's 10 centimeter. I'm just telling you a summary, okay? How to get the radius. Now in this triangle, you see this is R. This entire length is 8. Yes? So this much part over here, this remaining length, because this length is what? This is 8 and this is 6. So this is going to be what? This entire length over here This is 8 and this much length is over here is 6 over here. Correct? So from here, and this is also r, this remaining length is going to be 8 minus r. From here you can get this value 8 minus r whole square equal to 4 square plus r square. I hope this is clear. Yes? Quickly. Crystal clear, Janil? Yes? Ananya? So it's clear how we are getting the radius. Yes? All you need to use is Pythagoras theorem. You need to, build up a relationship between these two triangles somehow. Understood. Great. So we have radius 3 centimeter. Now we get the volume of sphere from here. That's 36 pi centimeter cube. I hope Surajpal, your doubt is clear now. But question is asking what fraction of water overflows? Fraction of water, right? So that means when we talk about the fraction of water, we would require the water that overflows divided by the total volume of the cone. Correct? The total volume of the water. What is the total volume of the water? That's actually volume of cone. 1/3 pi r square h. So 1/3 pi as it is. Radius is 6. Here 6 square multiplied by 8, that's 96 pi. So divide them, you get 3 by 8, 0.375. Yes. Yes. Mridul Chaudhary. One more time. Okay. So what we are doing here is to get the radius. I'm explaining one more time here. This entire length is 8. Yes. And over here in this triangle, this is 6. So from here using the Pythagoras, you can get the value of AO. That's going to be what? 10 centimeter. Right? Now I'm using this smaller triangle. This is R. OC is 8 and this is also R. So remaining length is 8 minus R. And this OD over here is entire OA over here is 10. This is 6. So this is going to be 4. Use Pythagoras. From here you will frame an equation. You get the value of radius. That's 3 centimeter. Using that you can get the value of the volume of sphere. That's going to be 36 pi. But question is asking what fraction of water overflows. Fraction of water. So you need the volume of the entire vessel also. Conical vessel. So that's 96 pi. Divide them. You get 3 by 8. 0.375. Volume of solid, volume of water rose. Yes, volume of water rose. But here in this case, we will not say that volume of water rose. Reason being, it was filled completely with water up to the brim. So definitely it will flow out. Understood, Kanagu. Okay. Disha Bhatt is giving thumbs up. Ananya. Yes. So it's clear to everyone? Yeah. Aman Kumar, great teachers are rare. Many of the existing teachers are there by chance and not by choice, and Byjus gives us that amazing chance. Thank you, Aman, for such positive words. 3 by 8 is fine. Yes, clear to everyone. Great. So this was the last question of today's session. Now homework time. So the diameter of a metallic sphere is 6 centimeter. It is melted and drawn into a wire having a diameter of the cross section of 0.2 centimeters. Find the length of the wire. You can try this question after the session and you can let us know your answers in the comment section below. And please, I expect each one of you to respond to this question. Yes? Okay, so I'll be waiting for your replies this time. Now, so as you know that we have lined up many more sessions from you from every Monday to Friday to make you exam ready. Now let me give you a glimpse of the upcoming sessions. So next session is on February 17th, that is Thursday, 7 p.m. We will be discussing statistics in one shot. I remember in the beginning of the session, somebody was asking me that when are we going to do a session on statistics? Yes. So in the next session, I'll be covering statistics, all the concepts in just one session. Yes. Sample questions. Are you talking about the sample papers? Yes. Keep pi as it is. Just check it out. Answer would be 96 pi. Yes. Yes, Keshvi, correct. 3 by 8. Community tab. Okay. You can post your answers in the comment section. I always see that. Who all have actually answered to it. Sample question papers. Don't worry, Fatima. We will come up with that as well. Don't worry about it. As you all know, we have got free trial classes also, and the link for that is given in the description, so you can get all your doubts clarified instantly during the class. And please like, share and subscribe so that you do not miss any new update from us. So I'll see you soon. Until then, take care. Thank you.